An important role of an information systems auditor is to be able to review and provide reports then on the effectiveness and maturity of the systems development process. This starts certainly with systems design. The objective of system design is to map out how does data flow through the organization. We map out the data flows. We map out the processes that transform or change that data. We then develop control frameworks to make sure that that data is protected adequately at all times, in all places on our systems. We want to put those controls in the right place to protect that data. We then define data dictionaries, what's the format and structure of data, so that data is represented in the same way on multiple systems. For example, I might have a customer account number. I want that customer account number then to be defined at a certain size, a certain format, consistently on all of our systems. Not where on some systems it's 7 digits or 9 digits. On some systems it's numeric, and other systems it might be alphabetic or alphanumeric. The idea of a data dictionary is I can know what data I have, how it then is represented, stored, processed, and transmitted, and therefore whether or not it requires special protection as well. Is it sensitive or critical data? We need to understand when we look at system requirements that how our system will fit into systems that are upstream that feed data to us, as well as how does our system interface with systems that are downstream that we feed data to them. Obviously, we want to be protected from somebody then infecting or in some way damaging our system through some type of an upstream feed that is wrong. And we also want to be, responsible to make sure that we are not going to then affect a downstream system by sending them data which is incorrect or duplicated, for example. There's a number of different system development methodologies that are in use today. The Agile system, for example, a great little system of breaking all of our tasks into small little pieces, working on each one, increasing the involvement between then users and developers and architects. So hopefully things are being developed in a very flexible, agile, but also in a very, should we say, manageable way through a number of small little projects rather than very large, cumbersome, and difficult projects. We then have things like extreme programming. Let's focus on what's important. Get rid of the unnecessary items. Rapid application development. To have a team that works together in many cases to really facilitate understanding the business unit requirements, design, development, testing of the system in a very rapid and, of course, also, again, flexible manner. A little later in this module, we'll look in more detail into computer-aided software engineering tools, or CASE tools. These can greatly help a developer both in developing and testing new types of applications. The idea of the clean room is to write code which is error-free. Code which is perfect the first time and doesn't require the additional effort to go back and fix it. This is the idea that if a developer slows down and really works on developing code which has been then tested and proven to be good at the beginning, will save a lot of work later on in the actual repair and fixing of that code. The Agile family then is based certainly on small little pieces. I like to call them Lego blocks of code. Each piece developed within a very short time period, iteratively. So we have then that whole process here of interaction, feedback, so that each little piece is being worked on as an individual quality piece of code, but that can easily and rapidly be changed if the requirements change or based on what we learn. The important thing is to prioritize our effort, often daily. Okay, what are we going to do today? We can start each little sprint and identify what the new requirements are, what a requirement we're going to address today. Now, this depends on the use of a small, highly skilled, and integrated team. The idea being that with a small, highly skilled team, we'll be able now to learn from the business unit, work with the business unit, to then design and develop code that will really meet the business unit's requirements. So instead of being a very drawn out process with often poor communication, we have an integrated team that works together. Now, there are risks with Agile. The risk that in some cases, well, if each individual unit is good, will they still be secure if we bring them together? Where's the documentation? In many cases, things are being done quickly without maybe taking a lot of time to truly document everything. And in some cases, of course, things are being changed without going back and reviewing or updating that documentation as well. So when an auditor comes in to then audit an agile development process, they have to be aware of some of these risks. Are these things being acknowledged and dealt with then by these teams? The idea of prototyping, and we've had many different types of prototyping models over the years, from rapid prototyping, modified prototyping models, iterative development. This is all about developing things as an evolutionary process. We turn around and develop, say, a prototype, provide that to the users, get their feedback, improve it. The whole idea that quite often, through a whole series of learn, and develop, we can then come out with a much better product in the end. It's iterative, and it's like, hey, let's try it and see how it works, and then we can fix it and make it better. This, of course, really requires a lot of good user feedback. It allows us to be able to continuously focus on the quality and improvement of the product. Now, the risk, obviously, with prototyping is that often a product prototype is, well, it's semi-functional. It does most of what the business needs, and they say, okay, let's put it in. We can do the last stuff later. But you all know how that goes. Very often things just never get finished. Those little jobs that we should have we need to do something, and we just didn't get around to it. And the problem quite often with prototyping is that everybody looks and says, hey, this is really great. We can improve on this even further. Which means we end up sometimes with this problem of scope creep, that things are continuously evolving without ever coming to a point and saying, hey, we've got to stop here and control changes to this, should we say, project. The idea of rapid application development is, again, a type of prototyping model with highly skilled teams, just like in Agile, and reusable code. The Lego blocks that we can assemble and, of course, take apart and reuse many times. We can say it's also a form of iterative design and evolutionary development, where we're getting that feedback, we're prototyping, how can we fix it, and so on. And very often, to facilitate rapid application development, we're going to rely on some of the tools that are available to us. The power development tools, testing tools to help us to be able to both code and test our product. But an important part of this, just as with Agile, rigid time limits. We set in place time limits to make sure that we're not trying to do too much every time. Component-based development was based on using building blocks of executable code. This was a derivative of the old object-oriented programming approach. When we did object-oriented programming, then we often built little pieces that could be called by different, shall we say, programs that needed a print functionality, or they needed a tax calculation functionality. And these little building blocks, or let's call it, like in the construction world, prefab code, I could just bring in and attach onto my system to provide a certain function. The idea being here that if I have now component-based development, I'll be able to reduce my development time by leveraging what we already have. What we already have has been thoroughly tested, so therefore I might reduce the problems and errors that could be introduced, thereby increasing the overall quality of my product. This idea of modularity and reuse is certainly valuable when it comes to being able to facilitate the building of systems within strict timelines and even budgets. Well, so many of our applications today are based on web. Web applications very often then will have to interface with some of our older legacy systems and the underlying infrastructure, quite often through things like APIs, application program interfaces. These are used then to communicate with lower level programs. The problem is that most APIs were developed with a lack of security. They don't have a lot of documentation. They're kind of a utility. They're just there and they work, but no one really has done examination of them. Make sure they're properly tested and that they are being operated correctly in a secure operating environment as well. The use of computer-aided software engineering, or case tools, and there's of course both high-level and low-level case tools that will help us in a lot of the requirements gathering, and in many cases can help us actually write pseudocode, or they can write preliminary code. The idea of a case tool is it can be used to support things like my data flow diagrams, my data dictionaries, and when they generate code, that can then be used as the framework or basis that we then just update and modify, saving a lot of development time in things that could be done through an automated process. Many of the case tools also support the testing we need to do, putting in place the ability to test the code functionality and security as well. Many organizations have to make a decision whether or not to buy software themselves, which has already been prepared by another company, or whether to build it themselves as a custom package to meet their own specific needs. There are many different considerations that have to be looked at in regard to which is the best decision to make. As an auditor, we are often required then to assess whether or not this process is being followed in a manner that is the best for the organization involved, with consideration of all these various elements. If we're going to build it ourselves, it's usually going to take longer. It's going to take time for us to build it, test it, work out all the flaws and problems we could have with it. The problem is that it then becomes an unproven product. Obviously, we are going to learn as we develop it, we're going to make fixes, and in many cases, we're going to make some mistakes. But the advantage is that when we build it ourselves, it is a custom product that will meet our exact requirements. This is a tremendous advantage because we then do not have to adjust our practices to meet then the ways that a vendor-supplied product then operates. The other advantage of building it ourselves is we know how it works. We have in-house knowledge of the product, and this can be a tremendous advantage when it comes then to the ongoing support of the product as well. In the end, this may be cheaper. Building it ourselves, we may save a lot of money that has gone into then the purchase and the brand name associated with a product that we are going to buy. If we're going to buy it, well, it might be available right now. It could be that we need to customize it still to meet our needs, but in many cases the delivery timeframes are going to be much shorter. We also then have a product which quite often has been in production for a while. It's proven, we know how it works, we know the reliability of the vendor involved. The problem is that we're forced to adapt to that vendor's way of doing business. Their product is built to work in some type of a boilerplate model, which, well, it's good on average, but it may not be exactly what is ideal for us. And we don't see the product at all. We buy a black box, we buy a function. We don't have any type of in-house knowledge that tells us about how that product works, whether or not it works reliably, how it's designed, and of course we're at the mercy of the vendor to fix any problems that they may encounter with that product. The other thing is, the vendor's in it to make money. It obviously is going to have the risk of being fairly expensive to actually implement or maybe customize to our needs. The purchase of software, or the software acquisition practices, is something that is also very much a concern for many auditors. How are we making the decision of which vendor to go with? What are the factors taken into account when we're looking, for example, with a vendor? What is then the criteria we have used of whether or not we use this vendor or another? These, of course, software acquisition practices, in the end, should have the goal to ensure that the solutions we have purchased truly meet the architectural needs and certainly integration with what we have in our organization already. We should ensure that any requirements, which include both functional requirements and security requirements, have been clearly articulated and documented in the request for proposal then that went to the vendors. This includes ensuring that the vendor is committed then to providing the necessary security and compliance support we will need. When we've gone out to the vendors and we've received maybe several different RFPs, we've replies to our RFPs, we will evaluate those vendor proposals based on the criteria we have set, what's important and which vendor perhaps delivers the best. Now, obviously, what is the best? The cheapest? The most functional? Sometimes there's, quite frankly, political considerations. The best vendor might be a local one rather than something from another country. We then select the vendor and write up the contract. But here it's important to ensure that, obviously, in the contract, all of those requirements that were back in the RFP are carried forward now into the contract. So we ensure that all of the topics were covered so that things don't kind of get missed or overlooked. Then, as the vendor delivers the product, make sure it's delivered on time, on budget, with the functionality, and of course the various support that was promised in that contract is actually then provided for us. One of the things that's a great risk to all software development projects is change. Now, change is inevitable. It's going to be rare that we're going to have determined the requirements exactly right the first time. We're going to have changes to the requirements, maybe changes to the functionality, changes to security that may be brought in by changes in the business, changes in priorities, changes in compliance and regulation. The point of change management is not to avoid change, but it's to manage change, to control the changes that are being made to our networks, softwares, projects, and of course, our device configurations. Change control should be a formal process, not something that's just done, well, hey, while you're in there, could you? No, things should be very carefully documented and then reviewed. We need to review that change to see, will this change potentially have an impact on project timelines, project budget, or even the security functionality in the project. Once we have reviewed it, and we've ensured that the impact of this change on the project is acceptable, that change will be then approved. Once it's approved, well, we make the change, code the change, test to make sure it works correctly, and then, of course, pending the approval of that completed change with all the testing completed, we will then schedule this change then to be implemented. And this, of course, should be done at a time which is convenient for the organization. There are many risks associated with change. The fact that somebody may put in a change which was not authorized, that the number of changes could cause the project now to exceed its budget or exceed its timelines. It could be that somebody takes advantage of poor management of version control or change to actually introduce malware into the executable or the product itself. and there's always the risk that a change we put in might bypass some of the security controls that we had originally intended to help protect that system and its data. We should review every change for its impact on delivery dates. Going back to the idea of the iron triangle, we cannot change the scope, the schedule, or the budget without changing the other two factors. One of the ways that we can measure how well are we doing. Are we progressing? Are we moving from where we are to a better level of maturity when it comes to systems development? We should be learning from every system. Every project that we have done should provide now information we can use to improve the processes related to new systems development or changes to existing systems. One of the ways this can be measured is through a capability maturity model, and the capability maturity model integration is especially suited for this. It will measure then the maturity of our systems development processes. Now there's 5 levels of capability maturity. The first level is initial, where at least we've recognized we need to have a process in place, but it's very reactive, chaotic, and in many cases kind of unplanned. And then we get to level 2. A level 2 maturity is still very often reactive. In other words, we're quite often just reacting to things that have happened. However, we are getting to the point now of being at least a managed process. We are managing and trying to ensure that the processes are being done correctly according to our requirements. Level 3 is where we become proactive. Now we have a carefully defined process, we follow it all the time, and we're looking as well to make sure that process is being executed in a standard, defined manner every single time. By the time we get to maturity level 4, we now have a consistent process we're always using, but now we're looking at measuring specifically various quantitative elements, such as delivery timeframes, such as change control, so we make sure that our systems are being developed according to a set of very mature processes. Level 5 is optimizing. At this point, our systems are well defined, and all we're doing is looking at the tweaking and refining of those processes just to make sure they're even better the next time.